Okay, so now we're going to look at the final section of this question. This question is from Chapter 4 on Consumer Choice from the University of London International Programme. This question will be relevant to any student studying a first year of economics module at any good university around the world. We have already explored the first two parts to this question, and so if you've missed that, then go back and watch those other videos before watching this video. Okay, so now we're told that Susan enjoys only bread and cheese when she has 500 grams of cheese for every bread roll that she eats. So, when we've been given a specific ratio in which the goods are consumed, that tells us that they are now perfect complements. And they will have the generic utility function of this minimum AX BY. Draw her indifference curves. How much bread and cheese should she buy to maximize her utility? Okay, so if we draw the indifference curves, because they're perfect complements, that tells us that the shape of the indifferent curve is going to be L-shaped, where the corner of the L is the consumption ratio. So her utility lines are going to look something like this. So we can call this one U1. And then if we draw on our budget constraint going through that point, so this will be her optimal bundle. And just as we had before, we'll put cheese on the x-axis and we'll put bread on the y-axis. Okay, so now we're asked to work out this point, what this point is. So to do this, what we first have to remember is that the budget constraint, what's the formula for the budget constraint? Well, the budget constraint is, the formula for it is M equals X times the price of X plus Y times the price of Y. If we then sub in this information that we have from the question, well, M is 12 because that's her income. X, we don't know because that's how much X she's going to consume. That's actually what we're looking for. Price of X is 3. The price of Y is 0.8. So these are variables because that's what we're looking for. But then we're told that she enjoys bread and cheese when she has 500 of cheese for every bread roll. So that tells us that for our utility line, the A and the B are 1, 1 because she enjoys bread and cheese in a 1-to-1 ratio. So 1 cheese for every 1 bread. So I've just put 1, 1 in here. So essentially at any point where we have an optimal consumption bundle, X is going to equal to Y. She's going to have the same amount of bread as she does cheese. So at any optimal point, cheese is going to equal bread. Yeah, doesn't matter. If we drew another utility line out here and we looked at this point here, at this point the amount of cheese would equal the amount of bread. So given that information, we can sub this into our constraint and actually solve for the amount of bread or cheese she would have given this amount of money. So when we do that, we get 0.8y plus 3y equals 12. So that's 3.8y equals 12. We divide by 3.8 and we get y equals 12 over 3.8. So y is therefore equal to 3.15789473684. No need to write all of that out, but that's the digit that should come out on your calculator. And then we know that x equals y, so therefore x equals the same thing. So here we know that this is just 3.158 to 3 dp, and so is this. But because we may be thinking, well, you can't have 0.15 of bread or 0.15 of cheese, so therefore we may actually say we'll just take it to the nearest whole number. So what she would actually do is she will consume 3 bread and 3 cheese. And then where that would actually be on our diagram, that would actually mean that she would be slightly under here. So maybe should be at a slightly lower level of utility, where it would be 3, 3. But the question doesn't say that she can't buy fractions of the goods, so this is an acceptable answer, even though it may not seem perfectly logical. Okay, so I hope that video was helpful, and I look forward to seeing you in the next video.